here we go. I feel like this property is extremely important. You will use it a ton in this class. You will use it a ton in geometry. You will use it a ton in Algebra 2. And if you don't grasp it right away, it gets really frustrating that you're getting the same thing wrong. So I'm going to try and break this down as best I can so that you do have an understanding of why you're doing what you're doing with this property. And hopefully then you will do it right come quiz or test. I will tell you right now, majority of the time when this property is done wrong, it's just because someone was rushing, because you have to distribute, you have to take a number and send it to two different or more, but in most cases for us, two different numbers. And people do it for the first one and then they forget to do it for the second one. So my advice to you is this: on the distributive property, slow down, take your time, and make sure you hit all the parts, okay? So I first just want to show you where they come up with the distributive property, what is actually going on. So I'm going to show you in picture form first, because my guess is somewhere in your math world, math life, you have done area equals length times width or base times height. Am I correct in that? Okay, that's not what we're doing today, but I'm going to use a picture of that to show you what it is we are doing today. Okay, so this is just me showing you visually, and then I will show you with numbers and variables. Okay, so here it is. You have a rectangle, and if I said the side of this rectangle has a length of 8, and then the other side has a length of x plus 5. Okay, when we find area, we multiply the base times the height, or the length times the width, however you want to think about that. So we would do 8 times x plus 5, right? Okay, well, here's how you can think of it in picture form. If I have that rectangle, and I know that this is 8, and I know I have x plus 5, God bless you. So if I cut it so that this length here is x, and this length here is 5. Okay, now it's kind of like, Dustin, up here. You with me? It's kind of like you can find the area of two different boxes right now, right? So this box here, the blue box, what would its area be right now?
8.
Michael, will you put your iPad away?
No.
8 times, you're taking notes right now? Okay. So 8 times x would be 8x, right? What would the area of the red box be?
5. No.
5 by what?
8.
5 by 8,
That's
right?
40.
This is 8, just like this was 8. So 5 times 8 is 40. So what happens is, if I want the area of the whole box, so the green, if I want the area of the green box, it would be 8x plus the 40 box. Okay? So what happened was, I was doing this, and I got this. What happens is you're distributing. You're taking that 8 and you're multiplying it by the x, and then you're taking that 8 and you're multiplying it by the 5. So 8 times x plus 5 becomes 8x plus 40. Okay, that is the distributive property. So if it helps you to think of it visually like that, you're welcome to do that every time. It's a lot more work, but you are totally welcome to do that if it helps you to see it. Okay, I typically am just going to give you the numbers and symbols and show you the distributive property, not with the pictures. Okay, so let me show you one without pictures and see if we can come up with what this would be. So if I have 2 times x plus 3, Okay? Distributive property says I'm going to take the number outside of my parentheses and I'm going to multiply it by both of the things inside. So I'm going to go 2 times x, which is what? 2x. Okay? And then your symbol is going to stay the same, so plus. And then you're going to do the 2 times your second thing. 2 times 3 is 6. So 2 times x plus 3 is just 2x plus 6. Okay? What if, instead, it looks a little different? X minus 4, and then the numbers behind it. Okay? What's the number that's going to get distributed to the other numbers? The 6. Okay? So we're going to take this 6, and we're going to multiply it by both numbers. So 6 times x is what? 6x. What operation are we doing? Minus, because we're subtracting here. And then 6 times 4 is 24, okay? Now, where you need to be a little bit careful with this is you cannot do 24 minus 6x, right? 6x minus 24 and 24 minus 6x are different things. So be careful with that. It doesn't work to do them reverse, okay? All right. So I'm going to give you a few of these right now, and we're going to work them out together. Example number 1. So when you're doing distributive property, they're just going to say simplify. Okay, so my first one here is 3 parentheses x plus 8. So if we're going to distribute this, what do we do?
You multiply 3 in x and then 3 in 8.
Right, so 3 times x gets us what?
3x.
3x plus, because we're doing addition here, then what? 3 times 8 is 24. Okay. Next one. So we have 2y minus 1. And then this one's a little bit tricky because now it's not a number that we're distributing, it's a variable. Okay? So take your time, think through this with me. Yeah, Jada.
It'll equal negative 2y.
Close.
Negative 3y.
What's y times y?
That's
Y.
1.
Y squared, right? Y times y is y squared. So you would have a negative 2y squared. And then plus or minus? Minus, okay? And now it's a negative y times 1 is what?
Negative 1y.
Negative 1y. So here's where you have to do a little bit more work because it's minus a negative. That becomes plus a positive. So you actually get negative 2y squared plus, and 1y you can just call y, okay? Dustin, do you need to move? Okay, then lock it up. So negative 2y squared plus y would be your final answer, okay? That's about as tricky as they get. All right, how about this one? You have 4 plus x and 11 over here. When you distribute, what's your first term going to be?
11 times x.
11 times 4, right? We want to start with the first one. So that is what? 44. Okay, plus or minus? Plus
11x.
11x. 11 times x is 11x. So that would be your answer. 44 plus 11x.
Can you do one like B?
Yes, but let me keep going with, I want to make sure I get through all of my examples first, and then I can go back and do another one like that. Okay, how's this one? This one looks a little intimidating because there's a fraction, but you just need to break it down little by little, and it's really not so bad. All right, so 3 times 1/6 x plus 2. So when you distribute this, you're going to do 3 times 1/6 x. Okay? Now here's the thing. If it helps you to write it, 3 times 1/6 or 3 over 1 times 1 over 6 times x, you can do that. Okay? You don't have to, but you can. And then 3 times 1 is 3. 1 times 6 is 6. So it's 3, 6, x, which is really what? 1/2, okay? So you're going to call this 1/2 x for the first term. Then you do your second term. 3 times 2 is 6, and we're adding. So it would be 1/2 x plus 6, okay? So don't let those fractions freak you out. Just turn it into a fraction times a fraction where you multiply across, and then reduce it. Okay, or you can cross cancel, but I feel like most of you like to multiply across, right? Okay, how about this one? 5 times x minus 7. What's your first term going to be? 5 times x, so 5x. And then it's minus, because we're subtracting, and then you do 5 times 7, so 35. Okay, questions on that? Okay, Jada, you wanted one like B, the second one?
Yes.
Okay, so what if we do 3x plus 1 times negative x? Okay, you're going to distribute that negative x to the 3x. So 3 times, this is essentially, if you want to think of it this way, there's a negative 1 there, right? Out in front. So 3 times negative 1 is what?
Is 3x squared?
Negative, because it's 3 times negative 1. So negative 3x squared, because it's x times x. And then negative 1 times 1 would be a negative 1. Now here's the thing. You can say plus a negative 1, or you could say just minus 1. Right? Because plus a negative and minus a positive would be the same thing. So if you like to do it that way better, you are welcome to do that. And then it's an x, right? Negative 1x times 1 is a negative 1x. So it's a negative 3x squared minus 1x, or you could say negative 3x squared plus a negative 1x or a negative x. But again, that's as fancy as they get. That is not typical. You won't see a lot where you're distributing the x's like that quite yet. We're trying to keep it real simple in this first lesson, okay? Questions on that? Okay, then here's what we're gonna do next. And this is very similar. It's just breaking it down a little first. So if I have a over b, remember that you can write that as a times 1 over b, okay? A times 1 over b, if we then multiply it across, would become a over b, right? So these two things are the same. You're going to use that idea, you're going to use that principle on the problems I'm going to show you next, okay? Yes, ma'am.
Well, like when it says like a over b, I always thought of it like a divided by b.
That's true. It's also a times 1 over b is the other way you can think of it. So it is a divided by b as well. But for the sake of how you're going to see these problems, you're going to need to kind of think of it like this, okay? And I'll show you right now, and hopefully it makes sense to you. So example 2. Okay, you are going to write the sum or difference, and they're going to give you something like this. So it's going to be 7x plus 2 over 5. Okay, so think of this as this part of it is your a, and this part of it is your b, right? And we said a over b, you can rewrite as a times 1 over b. Okay, so here's what I would do. I'm going to take away the red so I'm not confusing you with extra letters and numbers. I'm going to take that 5 It's a denominator right now. So I'm going to turn it into a fraction by itself. What fraction would it be if there's a 5 on bottom? What are we going to put on top?
One.
A 1, okay? So we're going to turn this into 1/5 times this top portion, 7x plus 2, okay? And now it's the distributive property. So what you're doing when you distribute this is 1/5 times 7. We're just going to call 7/5, okay? So 7/5 x, and then is it plus or minus?
Plus.
It's plus. Okay, now 1/5 times 2 is 2/5. So this would be our answer, okay? Now look at what we started with. You have 7x over 5, 7x over 5, and 2 over 5. 2 over 5. So I don't even necessarily need to see this part of it. If you want to just break it into 2 separate fractions right off the bat, you can. Let me show you what I mean by that. So I could say for this one, if I have 4x minus 16 over 3, okay, I can do this fraction, so 4x over 3, and then keep my sign, the minus, and then I can do this fraction, 16 over 3, and that would be my simplified version, right? I'm just using that 3 twice to turn both those parts into fractions. Yes.
Will we have a lot of these problems on homework?
There's not a lot of these ones. There's a lot of the first ones. There's less of these. Okay? Let me show you one more time the kind of shortcut version. So 4 minus 2x over 8. You're going to turn that into 2 fractions being subtracted. Okay? So it's going to be 4 over 8. And then are we adding or subtracting?
Subtract.
You're subtracting. That's this guy. And then you're going to do 2x over 8. Okay? But now here's the thing. That's not my simplest answer. How can I simplify 4 over 8?
Divide by 2. 4.
Divide by 4, right? So divide both by 4, I get 1 over 2. Okay? Still subtracting. What's 2 over 8 reduced? 1/4 times x. Dustin, go sit in the back for now.
Okay.
And don't speak.
Okay.
So 1 over 2 minus 1 over 4 times x, okay? So that would be your most simplified answer. Does that make sense?
Yes.
Okay. That's what we're doing today. Now, if you want to turn it, I mean, you are welcome to do this process where you turn it into a distributive property problem and distribute. I feel like it's more work, but if that's how you see it better, go for it, okay? But really what's happening is you're just taking each number up top or each term up top and putting it over that denominator and making it 2 separate fractions. Any questions on that?